We now move into the pancreatic secretions. Remember this first line, isotonic fluid, low flow, high, we're here right now. So look at this line. It says low flow, high fluoride, high flow, high hydrogen carbonate. What does this mean? It means that the pancreatic duct secrete bicarbonate, hydrogen carbonate, using chloride exchange mechanisms. So basically, what happens is you have these two exchanger. You have CFTR chloride channel that secretes chloride into the lumen, and then the chloride hydrogen carbonate exchanger brings the chloride back in and secretes the hydrogen carbonate out. The first step is the CFTR pump chlorides into the duct lumen, and then the chloride comes back via chloride hydrogen carbonate exchanger. So the hydrogen carbonate is secreted into the lumen. The result is a bicarbonate rich pancreatic juice. What happens is in cystic fibrosis, the CFTR doesn't work and chloride secretion decreases. Since the chloride secretion decreases, you have a decreased hydrogen carbonate secretion. So you get thick, sticky pancreatic secretions and you get duct blockage. So look at this. In cystic fibrosis, this CFTR doesn't work. You get decreased chloride secretion and decreased hydrogen carbonate secretion. So you get a thick, sticky pancreatic secretion, which causes duct blockage. Now, pancreatic ducts use the chloride through the CFTR to drive the hydrogen carbonate secretion. Now, we have some enzymes here. So, all these enzymes are pretty important. The pancreatic secretions basically secrete the alpha amylase for starch digestion. For lipid digestion, it secretes these lipases, but it also takes help of the bile salts and the bile acid. The bile fluid, and also it secretes the proteases. The proteases are most important. The proteases are basically all secreted in the form of precursors. This trypsin, chymotrypsin, elastase, and carboxypeptidases are all secreted in the form of precursors. They're secreted in the form of precursors because the pancreas will eat itself if they are secreted in the active form. Because these enzymes are supposed to digest proteins, and if the pancreas itself secretes it in the form of active enzymes, it will start eating itself. So to protect that mechanism, they are secreted in the inactive form, and then the duodenal brush border enterokinase converts the first enzyme, the trypsinogen, into trypsin, and that leads to a positive feedback loop, and then that converts the other precursors, chymotrypsin, elastase, and carboxypeptidases, into active forms. Now, the first thing was amylase. Alpha amylase takes this dextrin and converts it into limidextrins and maltose, isomaltose, and maltotriose for further digestion. The lipases go ahead and look at this picture. The most important thing here to see is this yellow box where the lipase is basically taking these triglycerides and converting them into fatty acids. What does the bile do? The bile takes these large fat droplets and emulsifies them into smaller fat droplets, right? And so emulsification is also there, and this lipase is also converting these triglycerides into further fatty acids. And then we have our proteases. So this brush border enteropeptidase, this enterokinase or enteropeptidase in the duodenum brush border converts this trypsinogen into trypsin. And this trypsin converts more trypsinogen into trypsin. It's a positive feedback loop. And then you have all these four separate precursors of chymotrypsinogen being converted into chymotrypsin, proelastase converted into elastase, procarboxypeptidase being converted into carboxypeptidase, and prolipase being converted into lipase. So this is all happening because the trypsinogen is now converted into trypsin by the enteropeptidase in the duodenum brush border. And so our body maintains this in the duodenum because all these yellow active enzymes would eat the pancreas itself if they are secreted in the active form. So they're not secreted in the active form. The duodenum converts them into the active form. So that's something for you guys. That's our pancreatic secretions right there.